Hi, this is Mr. Alexander, and today I'm going to talk to you about finding correlation and the equation of the regression line in the calculator. This is for IB Subtopics 4.2 and 4.3. So in your calculator, the first thing you need to do whenever you're trying to find the correlation or the regression line is, in your calculator, do second 0, scroll down to diagnostic on, and hit enter twice when you get down to diagnostic on. What this does is allow your calculator to pull up the correlation coefficient R. So when I'm asked the question, or when I see a question like this, the table shows the distance traveled by the train between various places in India and the cost of the journey. And we're given the distance in kilometers and the cost in rupees. We're asked to find the correlation coefficient R and comment on your result. Well, I can do that in the calculator, and the way I'm going to do that is by going to Stat, Edit. In List 1, I'm going to type in all those distances: 204, 1407, 1461, 793, 1542, 343, 663, 780. And in List 2, I'm going to type in the cost, or the Y's. So 390, 2200, 2270, 1390, 2280, 490, 1200, and 1272. To calculate the correlation coefficient R, it's simply stat calc 4 for linear regression. Your X list is in L1, your Y list is in L2. And we can simply calculate that. And right at the bottom here, that's our R value, our correlation coefficient. So in part A, R equals 0.994, 3 significant figures. And it says to comment on that, you would say this is a positive correlation. And you would also say it's strong. Now, it's going to be strong anytime it's higher than 0.8. It'll be moderate if it's between 0.5 and 0.8. It'll be weak if it's between 0.2 and 0.5. Less than 0.2, we'd say there's no correlation. In Part B, it says find the equation of the regression line, which we've already done. It's right here, y equals ax plus b, and it gives me the a and the b. So it's going to be y equals 1.47x plus 116, just using 3 significant figures there. And then in Part C, it says use the equation to estimate the cost of a 1,000-kilometer train journey. So that means that x is 1,000. So in Part C, we would simply do 1.47 times 1,000 plus 116, which is 1,586 rupees. And that's the whole process. So let's walk through the whole process one more time. So I'm looking at number 2 right now. And it says different weights were attached to a vertical spring, and the length of the spring measured. The results are shown in the table. We've got the load in kilograms and the length in centimeters. We're supposed to find the correlation coefficient, the equation of the regression line, and then we're supposed to make an estimate when we know the number of kilograms. So let's act like we haven't done anything. I'm going to act like this calculator's been cleared. Second plus 712. Brand new, first time I've touched it. So I need to go to second 0, scroll down to diagnostic on, and hit enter twice. Diagnostic on, enter, enter. And now I can go to stat edit. In list 1, I'm going to type in those x values: 0, 2, 3, 5, 6, 7, 9, 11. And in list 2, I'm going to type in the y values of 0.15, 16.5, 17.5, 18.5, 18.8, 19.2, 20, 20.4. So stat calc 4 for linear regression, we're going to calculate it. Our value of R is 0.731, which we would say is moderate strength. And it's definitely positive. And then to find the equation of the regression line, I've got it right here on my calculator. To 3 significant figures, y equals 1.33x plus 9.21. Use your equation to estimate the length of the spring when the weight of 8 kilograms is added. So our x value is 8, so I'm going to do 1.33 times 8 plus 9.21. That's going to be 19.85 centimeters, just like that. And that's basically the whole thing. This is pretty simple. Next time we'll talk about doing this all by hand, which you'll need for the internal assessment. But for now, this is sufficient. So thank you for watching. We'll see you in the next video.